In a previous video, we simulated the impact of vote shifting on the first digit distribution based on the Benford's law, and we did not find any substantial deviations. So the first digit distribution does not work, could not detect any voter fraud, or at least from the vote count perspective. So here's one example. Suppose the vote count is 1 million for a candidate, and the shift is 30%. Apparently, it will increase to 1,300,000 votes, and the first digit remains at 1, whereas the second digit changed. So in this video, we are going to examine the second digit effect based on the Benford's law. And the action is to shift a certain percentage of votes. So we first run a simulation, and then we observe the real data for different states, and to see if we can observe any deviation from the Benford's law for the second digit of the vote count. And for the first digit, the distribution is something like this. So number 1 should appear about 30% of time, whereas for the second digit, so there are 10 choices. So before the second digit could be 1, so it could be 10, 20, 30. So we add these probabilities together to arrive at 11.97% for the probability of 0 at the second digit, and so on and so forth. So it's a declining percentage. And let's run a simulation and see if we can find out any impact on the second digit. So that's what we have found in the previous video. For the first digit, the distribution is this black curve. So we can see that the vote count, the left digit or the first digit, conforms to the Benford's law. So it matches the black curve, which is predicted by the Benford's law. Now let's look at the second digit. So the second digit probabilities are like this. It's just a black curve, a black line, okay? So it's plotted black here. So what we are going to do is, these are the real votes, the number of votes received by each candidate. What we are going to do is we are going to shift a certain percentage from one candidate to another. Suppose we shift 15%. So the way we do it is we just increase this vote count by 15% of another candidate's vote. So this vote count will get increased, and so on and so forth. And we can see that without the vote change, so it's the blue curve. And if we shift by 15%, it's a red curve. And we can see the red curve will deviate more relative to the blue curve to the original. So if you shift 25%, you see the deviation is even more. So in a sense, we are alternating the naturally occurring number series. So we just added some man-made factor. And 35%, you see there's much more deviation. And of course, this is just a simulation based on what we have, the data, the county data for the presidential election. And if we use a different data set, you may reach different conclusions. but our focus right now is on the presidential simulation. So with this simulation, apparently we observe some effect on the second digit distribution if you shift votes from one candidate to another. So as I discussed, the first digit we may not observe significant impact. However, there are visible impacts or deviations on the second digit. So that's a simulation. And what we really want to do is to look at the state level data to see if there are significant deviations from the Benford law for the second digit for selected states. So now we have the state level data. So for the overall country level data, we can see that the blue columns and the red columns, these probabilities of the 0 through 9 serve as the second digit conforms pretty much to the Benford law. So overall, I think in the country, throughout the country, aggregated, there is no widespread voter fraud, at least from the perspective of the Benford law for the second digit distributions. And then let's look at for different states. And for Illinois, for example, we can see that it's matching the black curve distribution, but there are some deviations. But overall, there is this downward trend predicted by the Benford law. Let's look at another state. So let's look at Vermont, for example, just to establish some benchmark. And here we see it's quite close to the curve. Okay, so we may say that the results we observed from the Vermont county vote count conforms to the Benford law. Now let's look at some states that are controversial. Look at the results. Let's look at closer to Wisconsin. You can see the curve does not show that downward trend anymore, and we see visible deviations. And the reason you see for both candidates there are deviations is if you shift votes from one candidate to the other, you literally alter. Basically, you changed both theories, so you added human factors there. And if we look at Pennsylvania, for example, we also observe some substantial deviations from the Benford law for the second digit. But overall, what I have seen is, if you look at another one, Nevada, because it does not really not have a lot of data points, then I don't expect Nevada going to be conforming to the Benford law because you just don't have enough data. You see, it's all over the places. So overall, to use the Benford law properly, we need more data points. If we have a detailed data set, then again, Benford law is just one of the tools we can use to see if there's any probability of voter fraud. And there could be a lot of false positives, false negatives, and so basically you cannot just count on this one tool. Nonetheless, it is a tool that is used a lot in the accounting fraud and others. So it will be interesting to look at the presidential vote count from the perspective of the Benford law. And a lot of videos has examined the first digit. And in this video, we look at the second digit effect. And we found some deviations, but as we have seen that the number of data points just don't have, based on the number of data points we have, we couldn't make meaningful conclusions. So you may play with this data set and see what kind of conclusions or findings you may get. Thank you for watching this video.